In this video, we're going to talk about inheritance. We're going to build a system where we have a common base pickup object, and then different kinds of pickups like collectibles, speed increases, health, and then show you how you can expand it for other kinds of mechanics that you might want. We'll also talk about the template method pattern, what that is, and how we can use it when we're planning our systems. By the end of this video, we're going to have a base pickup that we can define a lot of functionality on, and leave one particular part of it open to be changed by our child objects. So we can pick up our base, doesn't really do anything. We can collect things, adds to a collectible count, and then we can have a speed increase. So we'll just see different ways that we can use our inheritance system to create a lot of different kinds of pickups, a lot of different kinds of functionality very quickly and efficiently. Before we actually start building our mechanics, I want to give a little breakdown of our approach. So this is going to be called the template method pattern. And what that means is we are going to have a base class that does all the boilerplate stuff. Like you don't want to copy paste collision detection, setting up the mesh, playing the sounds, all that stuff. You want to handle it in one place. This will be the base class for our pickup. And at some point, we want to define a method where child pickups can do very specific functionality. So for example, a collectible, when it is picked up, will behave differently than a health pickup, that when it's picked up, it will refill the health. A collectible might look at the inventory and add one. Maybe a speed increase would look for the character movement and adjust the walk speed. We don't want to do all of this on every single pickup class we make. We want to do just the base stuff and then define a specific method that can be overridden by the child classes to add our variation and do more specific things. So this is the approach we're going to take for our pickup class. It's a very effective approach whenever you need a lot of setup and base functionality and you just want to redefine one particular part of your class. All right, back in Unreal, if I hit the play button, you can see I'm using the third person template for my game. So I'm going to back out of there. This approach will work in any of the templates or any kind of game type you're using, since we're talking about a design of a modular system and not a very specific mechanic. So the first thing I'm going to do is I need to make my base pickup because I have all different kinds of pickups that I want in my game. I want to get all the base functionality in one place and then have a hook in for a pickup function or something that all the other types of pickups in my scene can then inherit from and redefine what happens when they get picked up. So for this example, I'm just going to do, I think, a collectible child pickup and a speed increase child pickup. That way you can see how the variation would work. But you could have an infinite number of pickups once we define a good base class. So let's make our base class first. So this is a fresh project. So I'm going to make my _game folder at the top. This is just a personal preference. You don't have to do this. As long as you put it somewhere, let's make a new folder, call this blueprints. And inside of here, I'm going to make another folder called actors. Inside of this actors folder, I want to make my pickup base or my parent pickup object essentially. So go up to blueprint class. This is going to be an actor since it's just a thing that has functionality in the world. So actor. And I like to name my base classes with BP underscore what the thing is. So pickup and then base at the end. Now naming preference will just always depend on the project. Name yours however you want. But I'll show you why this will help us make sense of things in a second. So our pickup base is going to have all our base functionality. We're going to define the looks, the visuals, the sounds, the detection, all that stuff that we want to be common to all pickups. And then we'll have the functionality for our child actors later. So let's start off with our visuals. Let's open up our pickup base. And for all of these examples, I'm going to use either the starter content or the basic shapes. You can always import your own static meshes, and I actually encourage you to, but I'm just going to keep this quick and as simple as I possibly can. So I'm going to come over here and add a cube, but really you could just add a static mesh and then choose some other mesh if you wanted to do it that way. You know, one thing I am going to do is rename this to static mesh. The only reason I chose the cube option instead of the static mesh is just so that we get the same cube for the tutorial, so that when we resize it, it looks the same. But you can use your own meshes if you want. So one thing I'm going to do is I'm going to come over here and change the material to some other material. I think one I found, mi_template. You usually want a material instance. It's a lot more optimized. So base orange metal, I think is fine. You could also make your own. I think that would be another good thing to do. I'm going to compile, save, and I'm going to show you something. When I drop this in the scene like this, see, it's very big. So I'm going to make this smaller, but you would want to test your own static mesh and see how big it is in the scene. we want it to look like a collectible. So I need to make mine a lot smaller. Now you have some options here. If you were importing your own static mesh, you'd probably want to import it at the correct size. For prototyping, I'm going to just make this smaller since I'm just trying to get a feel for what kind of object I need. But if you're importing your own, you may want to get it at the exact size you want on import at 111. If you really need to, you can resize like I'm doing, but ideally you would import it at the correct size you need. So 0.3, 0.3, 0.3, let's check it. All right, that's pretty good. So let's come back in. Another thing I want to check is I want to turn off the collisions on my static mesh. I'm going to do my collisions from an overlap from a separate collision volume. That way it's more modular. So come down to your static mesh, whatever you're using, scroll down, and this collision preset. So we're going to turn this on to no collision. Compile, save. And speaking of collision, I also want to have my collision detection. So I'm going to come over to add sphere collision right here. This way I can just change the radius on all my child objects and match whatever other kind of meshes I need. So let's actually call this sphere collision. I think would be a better name. Compile, save, and we can keep the default, I think is fine, but we can always tweak that later if we need. And the last component I think I want is a rotating movement. Type in rotating, add this. This will make the object spin around, and we can just input some values up here. So if I select rotating movement, we can make it move across any axes we want, but we probably want some kind of movement for any pickups that we make. So any child pickup based off of this, we do want to have some kind of rotation, but we could always make it rotate differently if we want. Oh, and one last thing I want to mention, notice that I am keeping my default scene root and my sphere collision and static mesh. This separation here just gives us more variability on our child objects if we had a different kind of static mesh or we wanted to place the collision somewhere specific. I'm just going to keep it this way instead of making one of these the parent. This is our setup. Let's compile, save, and check it out in the scene. Okay, looks pretty good. There's no collision, so I can walk straight through it. All right, and this is going to be our component setup for our base actor. Now let's add our base functionality. And this is the stuff that we don't want to put in every single child. We want to be common across all pickups. So open it up and go to our event graph. So what I want to do is when the player pawn enters the sphere collision, I want to run some kind of pickup function and destroy this actor. Generally, I would want my pickups to destroy themselves. You could always add an option to destroy or not if you want, but I think for me, the base functionality will be pick up and disappear. I'm going to delete out the other stuff because we don't need it. Select your sphere collision, scroll down to on component begin overlap, hit the plus button. So this means when something enters a sphere collision right here on overlap, then we will get this notification here. We want to test the other actor. So the other thing that overlapped this pickup and type equal, and I'm going to pull off and say get player pawn. Now I don't need to cast here because I don't care what the player pawn is as long as it is the player pawn. If they're controlling something that touches this pickup, then I want it to pick up. So if the other actor is the same as the player pawn, we'll branch, plug in this condition, connect it right here, pull that down. And at this point, we know the player overlapped this collision. So what we would want to do here is we would want to print string pickup. And then we want to destroy actor. So we'll see this little pickup message if we did this correct. So let's pull that over a little bit, compile, save, and test that our collision is working. Hit play, we should see pickup and the actor destroy. Perfect. This is our base functionality. Another thing that I think I want all of my pickups to be able to do is to play a sound whenever they pick up. Anytime you have an important gameplay event, you almost always want to play a sound, and I can't really imagine a scenario where I would not want to have a sound on a pickup, but I would want to be able to change out the sounds, so let's look at how we can do that. So the first thing I want to do is either create or find some sound effects and then import them into Unreal. So I have some that I already created, but you could go to Chiptone to create some sound effects. I've done a lot of tutorials on that. You can find them online, or you can just use the placeholder ones inside the editor if you like. Either way, let's make a new folder and _game audio. And I'm going to import my 3 sounds into this folder. Drag those in. So just to show you how these sound. Right, they're different enough, but they all sound kind of like collectibles. For now, they're kind of placeholder. So let's select all this, hit Control S to save. I'm also going to make a queue out of each of these. So I'm going to Shift, click, select them all, say create multiple queues. This will make a queue out of each one. Shift select all of these, Control S. And for each one, I'm going to come in here and add a modulator, pull off of output, modulator, plug that in. And I'm going to do this for all three. So I'm going to time lapse the other two, but this is pretty much all I'm doing. This will add some variation to when I play this sound. Save. And then we'll do the other two. Okay, and once you have all three cues set up however you like them, I'm also going to close out those windows to get them out of the way, close them out. All right, so now that we have our cues, we just need to play our sound and our pickup bass. So before we pick it up and then destroy, I'm going to play my effects over here. So I'm going to pull off right here after the branch and say play sound at location. Pull that up. I'm also going to get the actor location of this pickup bass. So right click, get actor location. This is where I want to play the sound. And the sound I want to play is, let's do collectible 1 for the bass. Type in collectible 1. Okay, this is our bass one. I'm going to pull this out a little bit. So we are playing the sound effect. I want the designer to be able to choose in each of the children and select a different sound effect, meaning that this needs to be a variable that the child actors can access. So we don't want to play this sound all the time. We want the designers to play a sound designated in a variable. So I'm going to right click, promote this sound effect that we're playing to a variable, pull that down over here. I think we're going to relabel this to be pickup sound. Make it instance editable so that the designer can choose. I also want to make sure that they're selecting a sound and not just clearing it out, because if there's no sound in the variable, that's a null reference problem. So we'll pull off and say is valid. And we're only going to play it if they selected a sound effect. So is valid true, then play the sound, move some of this around a little bit. Okay, and the last thing I'm going to do here is I'm going to select my pickup sound and go to category and type in bass FX. This way it'll group any variables that I mark under this category under this little drop down. So just pretty handy for compartmentalizing some of my information. Let's compile, save, and take a look at it. You can see if I select my pickup bass, I can see my bass effects here, and I can select a sound to play. So the designer could go and they could swap it out on the children later on if they want. So this is what I want. Let's test it out, hit play. Okay, pretty good. We have our sound effect playing on the bass, so we don't have to copy paste all of this play sound code. When we make a child, all we have to do is make a child and select a new sound. So this is exactly what we want. Another thing we probably want most pickups to be able to do is to play some kind of particle burst. When we pick up, we want particles to shoot outwards, and we want to be able to customize that a little bit. So let's put that in our base class. Another thing that we don't want to have to copy paste for every single pickup we make. Open it back up. I'm going to put this right after I play the sound. So I'm going to make space right here. And now I want to create the particle effect that I want to play. Now I'm going to keep this super generic and super simple. You can always do another tutorial to make this particle fancier and more specific. I just care about the functionality for this tutorial. So let's make a new folder here. Let's call this particles. And I'm going to right click, select Niagara system, new system from selected emitters, fine. Next. Scroll down to my omnidirectional burst, plus, and finish. Okay, we'll call this PS underscore pickup burst, Control S to save. Open it up. This is pretty much already doing what I want. I'm just going to change the color a little bit. So change the white to whatever color your base collectible is, the mesh that you chose. Mine's a little orange yellow, so I'll choose something like this. All right, save and close it. So we have our pickup burst particle, and we just need to play it inside of our bass pickup. All right, go back to your pickup bass, Control S, save, open it back up. And now we just need to play the particle effect. It's going to look very similar to what we did with the sound. So I'm going to right click, spawn system at location, plug this in, pull this over a little bit, plug it in, exit out, pull that into the front. Choose our particle to play. So our PS underscore pickup burst. Again, you can always modify that one to make it fancier later. I also need to choose a location to play it. So again, we're going to get actor location, or you could just copy paste it if you like. Pull that into location. This is where to spawn it. And just like over here, I also want to make that a variable. I want the designers to be able to choose inside of our child pickups which particle they want to play. Maybe they have a more specialized speed burst particle or something. Don't know. We'll leave it up to the designer. Let's right click and say promote to variable. Pull that over here. Let's rename this pickup particle burst. Turn on the eyeball for instance editable, and then also select the category. Once you create your first category, if you do the drop down, you'll see it in the drop down. So base effects, group it together. Let's compile, save, make sure that our default value is still set to our default one. Good. And now let's do our validity check. So pull off of our pickup burst particle, say is valid, do the question mark. So if we have one selected, then play it. Pull that up a little bit. Let's condense this some and let's try it out. If all goes according to plan, if we compile, save, and we test it, we should hear a sound and see a particle burst. So play. There we go. Okay, so this is our basic particle effects and functionality. Now, before I call this complete, I'm going to open up my pickup base again, and I want to clean this up a little bit. This is already getting kind of long, and I want to show you how you can condense this into functions. So select all of this, my is valid, play sounds, all the nodes related, all the spawn system at location, these four right here, right click and say collapse to function, like this. So we have our function over here. Let's move it all in. Let's also rename our function to play FX. So we know that if we double click, we can see everything related to playing the effects. I want to show you something. The first one is when we play our effects, we don't really want to stop, right? Stop our entire chain if we didn't designate a sound effect or if the designer didn't want a sound effect to play. We want to say if a sound is not valid, we do want to continue and try to play the particle. So I'm going to plug my is not valid into there. And same thing with our particles. If our particles are not valid, then we want to continue. We don't want to just exit and stop. Now you see that we don't have a return node here. You usually don't need a return node, but if you think you do, in this case, I do want to just verify that I still continue if it's not valid, then I can right click and just type in return node, add return node. And this way, if I plug is not valid into there, and I'll just connect this as well, it just reads a little bit better. So when I go back to my event graph, you see how we enter and we exit. It's just a little bit more clear to me. And I can also make sure that we are continuing even if we're not valid. And the last thing I want to show you regarding cleanup on this play effects function, go back to my event graph. Right now, other objects and eventually my child objects will be able to play our effects and access it and call it. We don't really want them to be able to do that. We only want to play the effects here. We only want to see it on the pickup base. In this case, we want to make this function private. This is called encapsulation in programming, which is only expose what you need to and hide things that other things don't need to see. So we're going to select our function, our play effects, and we can choose an access specifier. So public is anything can see it and access it. Protected is only children can see it and access it. But in this case, I don't even want the children to worry about it. I don't think they need it. They can always select different sounds or different bursts, and I think that is fine. That's already exposed to them. But running this function, I want to be private. So we're just hiding it by setting it to private right there and saying nothing else can see it if it doesn't need to see it. So compile, save, and now let's just verify that everything works before we consider our cleanup complete. Hit play, run over here, pick it up. Okay, perfect. It is working on our base. It is pretty clean. We've isolated it out into a function, hidden it with private, and now we're good to complete our system with our pickup. So at this point, we actually do want to create our base pickup function that our child actors can inherit from and override and do different things on pickup. We're leaving our placeholder here with our print string. This is where our function is going to go. But just to show you again, this is our reminder. It's probably starting to look pretty similar to our approach on our template method pattern. So we're doing things, we're detecting collisions and whatnot. We are playing our effects. Then we want to pick up right here, one step in the chain. We want to be able to customize how each object picks up right here in our child classes, our method to define. And then we are also destroying the actor. So we are doing this thing and then doing other things as well, potentially. You could do even more things on your base if you want. But the idea here is we are defining what happens on the children, not when it happens or how it happens. They just need to inherit and then do their own version of pickup. They don't have to worry about this. They don't have to worry about this. So that's the idea that we're trying to get across here with our approach. Compile, save, And now I'm going to make my pickup function. You could either do this as a function or an event. I'm going to do it as an event just so that it's very clear and easy and not hidden, but you could do either one. So let's remove our print string. I'm going to delete that. I'm going to right click and say add custom event. We'll call this pickup. And this is going to run on our base when something is picked up. So I need to actually call it here. So playFX, then call our new custom event pickup and plug it in. So on our base, we're calling this, so it's going to come down here and run it, but we're actually not going to do anything. We could actually leave a statement for ourselves just so you can see, print string, double click, base pickup. And this will probably help you see how the flow is working later on. But if we compile and save, we are doing all of our base functionality, we're running pickup, and then we're destroying the actor. Now, here's where things get interesting. When we create a child actor, what we're going to do is we're going to inherit all of this, but then we are going to specifically say, I want to do this, but I want to do it differently. So a collectible will look for an inventory or some collectible count and increase it. A health pickup might look for a health component and increase it. Our speed increase might look for a character movement and increase it, or you can look for an interface, whatever you want. But our child actors will redefine what happens right here in different ways. This way we have a modular system where we have our base do all the stuff, all the boilerplate we don't want to copy paste, and all of our child actors doing only the different thing that it needs to do. Now, another thing that we can do inside of this is provide things to our children that they might need access to in order to do their variation. In my case, I think that they might want access to the player pawn or whatever your system has right here. For me, I'm having the player pawn be the test for if this thing can be picked up. So what I want to do is run my pickup function, but send extra information. So in this case, I want to send the player pawn. We don't need to search for it again in all of our child objects. We already have it. So let's just pass it through and then they can receive it and use it to do their functionality if they want. So we're going to add an input here. Select your pickup, go to inputs, click add. And for me, since I want to pass through the player pawn, that's what I'm looking for. But you could, as long as you choose the correct type, you can pass in anything you want. I'm going to call this player pawn. You could also just do a generic other actor, but since I know it's a pawn, it might save me some kind of trouble. Purely up to you and your system. I'm going to do player pawn, and for my type, I'm going to type in pawn. Here, pawn, and I'm just going to do an object reference, but you could use the same process for anything that you want to pass through. So my other actor is the pawn. I'm going to, after I get player pawn here, drag it over, pass it into our pickup function. If it's an input, we need to provide it in order to run the function with that input. So then we'll receive it and do whatever. So here's a cool thing. Our child actors, when they override pickup, they automatically get the player pawn and they can do things to it because we're passing it through in the base. I know that's a little bit confusing, but it's very helpful to know that you can pass inputs in on your base so that your child objects don't have to do their searching. They're just receiving what they need to do their job. So now let's test our variation. The cool thing is we have our entire system. It's all in the base. I'm just going to show you how you can use it to create child objects that have different kinds of functionality. But really at this point, once you understand the process, you could make as many other things as you want. I'm just going to give you two different examples to show you a couple tips and tricks and just see what it looks like to make a child object. But these are going to be really simple examples that are not even meant to be, modular or clean or whatever. I just really want to show you the process so you can see how you can use this for whatever you want to use it for. So let's look at an example. Let's make one child variation. In this case, I want to make a collectible pickup. So the process is we select our pickup base. So our child object will inherit everything from the pickup base and then customize whatever we expose to it. Select our pickup base, right click, say create child blueprint class. Whenever we create it, it'll give us a name, but I'll tell you personally, I like the naming convention BP underscore whatever the specific child is doing. So we'll call it collectible. And then I like to name it whatever our base object name was. So pickup. So I'll call it collectible pickup. It just reads better to me if I have pickup base and then collectible pickup or health pickup or whatever. It's clear and it kind of ties it to my system a little bit inside of my assets. So once you create this, if you open it up, we can immediately begin customizing some of our existing components without having to remember what we put in all of our setup. So for example, one thing we can customize is our static mesh. Again, you could select a different one here. You could select the same one, whatever. In my case, I'm just going to make this a little bit bigger just to show you. 0.5, 0.5, 0.5. But you could import another mesh and just use that, or you could use one from the starter content. That would be fine too. Let's also select a different material just so it looks different. mi underscore template underscore base blue. This will be fine. So this will be a slightly bigger cube that looks a different color. We can also customize the other components if we want. Now, remember, we're just customizing this on the child. It's not affecting the base. We're just adding our variation on any of the variables and components that we exposed. On my rotation rate, let's make this one do 80, 100, 120. So it's going to be spinning in a weirder way than our other one. It'll look a little bit different. Compile, save. Now, since my mesh is bigger, our sphere collision probably needs to be a little bit bigger to compensate. To show you, we can also adjust this, right? So it's bigger, 64 I think is fine, compile, save. Here's the other cool thing. We were setting this up as a programmer, but the designer can do all this, right? We don't need a programmer to customize all the child objects. They're just making a new one, adjusting the collision, the mesh. They're not really adding any functionality. So this is very handy because we don't really need programmers to be messing with meshes and materials and all that if they don't need to. So we'll compile, save, and let's pull one into the scene just to test how big it is. So it's definitely bigger, right? But just to show you side by side, it looks different. It's probably going to spin different, right? So we're already getting some varying behavior just from changing some things on some components. Let's go even further. Let's make a different sound effect and a different burst and show you that process. So the first thing is we need to make sure that we have a new sound effect and a new particle burst. We do have a new sound effect because we already set up all three at once. So we'll just use Collectible 2. And for our particles, we need a new particle effect, but all I'm going to do is Control C, Control V. Again, you can make a custom one from a different tutorial. We'll call this Collectible Burst. And I'm going to change the color a little bit. So omnidirectional burst, we'll put that at, I think it's blue is the material we chose. Maybe we turn down the lifetime a little bit, make the particle burst just slightly different. We'll have it shoot out faster too. So scroll down to velocity. We'll do 75 and 1,000. I think that'll be good. It'll look just different enough. So let's minimize and come back. So we have our sound effect, our particle. Now all we need to do is plug it into our collectible. So go to actor, make sure you have collectible pickup, open that back up. And on the top, if you select self, you remember we created our base effects as variables. We just select a new one. So Collectible 02, do the Q. It looks like we didn't do the Q on the base, but it's fine since the base is very generic. And our pickup particle burst, we want this one to be our collectible. So we have added variation on the visual, the collision, the rotating, so the movement and animation, the sound, and the particle. A designer could have done all of that. We didn't even need to touch code, which is awesome for creating lots of different variation off of a base mechanic. So hit play, looks different, spins different, right? Different sound effect and a different particle. So this is all the simple tweakable stuff and all the effects and all the visuals and components, but we still need to change what happens when it's picked up. So now we want to add our unique functionality related to our collectible that is different from our base pickup. In order to do this, there's a lot of ways you can put a collectible on your player objects. I like to put mine in a player state. I know a lot of other tutorials will show you how to put it on the character. That's fine. The specifics really don't matter. I just want to give you an example of how you can add child functionality. What I'm going to do is I'm going to right click, blueprint class, and I'm going to make a new player state blueprint class, which is where we can hold all of our player information that doesn't need to be tied to a character. Player state there. Select, and I'm going to call this third person player state. Again, not super important if you don't understand this part. As long as you put a variable somewhere where you can access it, you should be fine. Let's also add the BP underscore at the beginning. Okay, there we go. Now, in order to use the third person state, we need to find the game mode. So there's a couple different places you can find that, but I'm going to find it in the existing third person down here with our template. Down here in third person game mode, we just want to make sure that we are assigning our custom third person player state that we just made. So the default is not really useful to us. We're going to select the BP underscore third person player state. This is what we want. Compile, save. And so now our level will use the third person player state instead of the default generic base one, which means that we can customize it. So let's go back into our blueprints. You can organize this in a different way. Like you can put this player state down there. Again, the specifics don't matter. I'm just giving you an example on how to use the system. open up our player state. Inside of here, I'm going to make a new variable. We'll call this collectible count. Make this an integer. We'll compile, save, make sure it defaults to 0. And if anything wants to add to the collectible count, they just need to get access to the third person player state and set the collectible count to something different. So now that we have our system set up, we can actually add the functionality back inside of our collectible pickup. I just didn't want to switch real quick, like while we're inside of here and set up a different system. Again, as long as you have a collectible account somewhere where you can get access to it, that's all we're going to do here. So let's open up our collectible pickup, and we want to redefine what is happening when we pick up. Now you may or may not see some parent nodes here, but I'm not going to use them anyway, so I'm just going to delete all this out. But if you wanted to add some additional things over there, you can. First, let's start with how to change what happens when we call pickup on the base. And specifically, this is called overriding. So over here under functions, if you hover around over here to the right, you'll see override. Click that, and we can override any of these functions, which essentially means define it in a different way. So I'm going to choose pickup. And so what this is doing, if I Control S, over on our base, where we're running this right here, we are saying instead of doing this, we want to do this instead. So as part of our chain, we're doing all our base stuff and hooking in right here and saying, no, I want to do my own pickup. And that's what we're doing in our child. But to show you another thing, let's say if you did want to do both. What if you had some additional functionality here, you wanted to run this and also add your own on top of it? Well, in that case, you could just get the parent. So if you right click event pickup after you override it and you scroll down to add call to parent function, you can get this node, plug it in, and you can put this anywhere you want, but this would mean run all of the base functionality right here and then also pull off and do extra things. I'm going to do this one this way just to show you, and then the other one I'll just do it without the parent version. But I just want to show you can run the base functionality in addition to what you do, or you can do it instead of if you take this out. So the first thing I want to do is I'm not even really going to use the player pawn, so I don't really need it, but I have it in case I did need it, and I'll use it on the other example that we'll do after this. So what I want to do is I want to get access to the player state that we just set up, and I want to test if it's the third person player state, the specific one, and if it is, then I want to increase the collectible count. So we're going to right click, get player state. In this case, casting is the easiest way to get access to this, but again, you really can do whatever you want on these child objects. I'm going to cast to BP underscore third person player state, connect it. So again, this node is optional. You don't really need it, but I'm just going to leave it in just to show you. And if it is the third person player state, we're just going to increment the collectible account, just add 1 to it. So an easy way to do that is pull off get collectible account. And we're going to pull off of that and say plus plus, which just means increment, add 1 to the current amount and set it. Or you could, put in the extra notes, do it the longer way. And then after that, I'm going to print string and print the new amount after we increment it. Now, this is just so that we don't have to set up a UI. I think that would take too long from the tutorial. But as we collect collectibles in our scene, we'll see the collectible count up, and we're just going to print it to the console. Compile, save, and we'll go back. We'll save this one too, just in case. And so that's it. I mean, really, we're just redefining our pickup event or function, if you like. We see both inside of this long list. We're redefining it to do the collectible thing, right? Which is test a player state, increase the collectible count, and then it'll hop back over here and it will destroy the actor on the base. We don't need to copy paste code, just change the part we need to change. Really quick, really easy. Let's minimize it. Let's duplicate a couple of these just so we can collect a couple. Hit play. Now I want you to see something. On our base, if we collect it, we see base pickup. On this one, we should see base pickup and collect because we're running the base functionality pickup and the new stuff that we added. Right? We see base pickup and then we see a number change because we're collecting up. So I hope this is starting to make sense on how you can build a reusable system where we can just redefine a small part of it and retain most of the base functionality, and we can then continue to add variation to our system. All right, let's do one more pickup variation. And in this case, I'm going to move a little bit faster since you've seen the process, but it is just repetition. It's the same thing we just did, just with different variation. And when we get to the functionality, we'll do more of a searching style, like get something from our pawn. So I'll show you that option as well. So let's just do something simple. We'll do a speed increase. In my case, just to keep it simple, it's going to be a permanent increase. You could do a temporary one if you want. I just want to keep this a very short example, but just to show you the process. First, we're going to select our base. We're going to create a child blueprint. We'll call this BP underscore speed increase pickup. We'll Control S to save, open it up, and then we're going to change our visuals and maybe our collision mesh a little bit. So for our visuals, just to show you that we can get a little wackier with it if we want, I'm going to change this to my starter content couch. I think it's SM couch. I guess to me, the couch is an opposite of a speed pickup, but it's fine. It's just for demo purposes. Pull that down a little bit. We'll keep this at 0.3, 0.3, 0.3. I think that's fine. We're also going to make our sphere collision bigger again. So 64 was a good number. This is going to be the visual and collision for our speed pickup. Let's also change the rotation. I think maybe let's have this rotate a little faster. So 240 on the Y. Compile, save. I think I also want to change this material down here. I think there was one mi underscore pyramid. Again, you should probably make your own material instances, but I didn't want to take time from the tutorial to do that. It's a little bit separate, but you probably should. All right, we Control S to save it. Let's put it in our scene. Make sure it's looking about how we want it. Okay, so we have the starting point of our speed pickup. For our effects, we need an audio, which we already have our Collectible 03, and we need another particle. So let's duplicate our pickup burst again. Control S to save it. Come into here, we're gonna change this real quick. Scroll down, I think a pinkish purple is what we had. I'm gonna make this one a little bit bigger. So for spawn count, let's do 200 instead of 100. And let's just get rid of the gravity just so it looks a little bit different when it's radiating outwards. So right here with gravity force, I'm gonna put this at -100. This will make it feel a little less floaty and more bursty, I guess. Control S to save. So we have our sound effect and our FX. Let's actually rename this particle to speed increase burst. Control S, make sure that's all saved. And let's go back to our speed increase pickup, select ourself, and we're still just customizing variables and all this. Let's select our Collectible 03 Q, Collectible 03 Q, our new particle burst, so our speed increase burst, compile, save, and let's test out our effects. Okay, so we are already getting a lot of variation very quickly. And now we actually need to add the functionality for our speed increase pickup. So let's go to our blueprint, speed increase pickup. And what we want to do is go to the event graph, delete all this, and we want to override our pickup function on our base. Remember, this is inheriting from our pickup base. So override right here and pickup. So we want to say, instead of doing this, I want to do this instead. In this case, I'm not going to run the base just to show you can do it either way. And I am going to use the player pawn that we're passing through. Now, at this point, you probably either want to search the player pawn for some kind of component or search the player pawn for some kind of interface or whatever you need for your system. I'm going to search for the character movement component to increase the walk speed, but you could very easily test if this thing implements an interface or search for a health system component or whatever else you need. We're using this player pawn and testing if it has a thing. So I'm going to pull off and I'm going to say get component by class. We need to specify the component to search for. I want the character movement component. Now, just to show you what I mean here is if I actually open up my third person character down here, my third person character, I'm literally searching through these components to find the character movement, this one. And then when I'm inside of here, I want to change a variable. This is a very specific example, but I think it gets the idea across. We're going to search for this character movement component. We're going to test if we actually found it. So in other words, is valid, do the question mark. So if we found it, if we found this character movement component on the player pawn, then we want to use that character movement component that we found and do something. So pull off and say set walk speed, set max walk speed. And then at this point, we can either adjust it manually, we can multiply it by a value or whatever. I'm just going to add an additional amount. And the additional amount, I think, should be decided by the speed increase pickup, maybe through a variable. So let's decide an amount to add to our max walk speed. Let's make a new variable over here, just some variation on the child. We'll make a new variable and call this speed increase amount. Make that a float. Probably don't need instance editable. We'll compile, save, and change the default. I'm going to make this really high just so it's noticeable, but if this was Bomberman or something where you want to add a little bit to the character's stats each time they pick it up, you know, you could probably go more subtle. I'm going to do 200. So set the max walk speed to, well, first let's get the current walk speed. So get max walk speed, that one right there. I'm going to get the current amount and add, so do the add and add our speed increase amount. So take the current amount add a new speed increase amount to it, and that's what we want to set it to. So add this small amount to our existing walk speed. Make sure that we plug this in. If it is valid, we do want to set this. Make a print string, a speed increase. All right, and there are lots of things you could do here, lots of different kinds of components or interfaces, or whatever your connection point is. I just want to show you how you can use a player pawn here and that you didn't really need to run the base class. So we are just redefining how our pickup base pickup function is working. We're just making it do something different. In this case, increasing the character movement speed or doing a collectible account or whatever. Let's actually compile, save this, minimize, and play. Okay. So we have our base one. We have our collectibles. And we have our speed increase. So we're not running the base. We didn't see that print statement. And we're also moving a lot faster. So I hope you see the power of this pattern here. We just created a brand new collectible in like 6 or 7 minutes. Has its own visuals, retains a lot of the base functionality, so we're not copy pasting code. We added new functionality to it using our overriding to our base function. We can customize it however we want. We can do whatever we want to the player pawn. We're not having to search it again. It's just a very handy pattern to know about. So here's the way I would encourage you to think about it. Because up to now you might be thinking, well, when should I use a component for my system? When should I use an interface? When should I use inheritance? I'm just giving you another tool. My recommendation, if you have a lot of base functionality that you need, so our player detection, our effects, destroy the actor, whatever, a lot of base functionality that you don't want to copy paste, but you need variation in some specific part of the function, like our template method pattern, I would recommend using inheritance. I think this is the best time to use it. Base functionality and then variation about how a specific part of it works. If you have a system that is entirely self-contained and only needs to be modified through variables, so the functionality doesn't change, but maybe the particles or the amounts or whatever, I think components are best for that because you don't need to change the functionality. You just need to change the data and the variables. Interfaces are best whenever you want to make a simple call and you don't want any base functionality. You just want to change something like a move interface where you can attach it and different things move in different ways, but you don't have a base functionality for moving. Hopefully this breakdown of inheritance and how we can use it is very helpful to you in building a lot of new mechanics. And I hope that you learned something new.